everyone, this is Akshara of CSE AML A section. Today I am going to present my PPT on review of probability theory and random experiment. This project is an overview of probability concepts, fundamentals and applications in random experiment. Content. So in this PPT, we are going to discuss about introduction, key concepts, definition of random experiment, sample space and events, types of events, axioms of probability, classical definition of probability, conditional probability, independent events, random variables. Introduction. So, probability theory is a branch of mathematics that deals with uncertainty. It provides tools to quantify likelihood of events occurring in the random experiment. It is used in science, technology, and everyday decision making. Key concepts. So the key concepts of probability are experiment, sample space, event, probability. Experiment. Any process that produces an outcome is called experiment, where the sample space can be defined as the set of all possible outcomes. It is universal. Event is denoted by E. It is a subset of a sample space. Probability. It is the measure of likelihood of an event. Definition of random experiment. So random experiment is nothing but an experiment whose outcome cannot be predicted. Like example, we can see tossing a coin, rolling a die, drawing a card from a deck of cards. So these are the examples of the random experiment. Sample space and events. So sample space is nothing but collection of all possible outcomes. Event. Event is one or more outcome of interest. Let's see an example. While tossing a coin, the sample space can be head and tail, where the event is head, or it can be tail. Types of events. There are many types of events such as simple event, compound event, certain event, impossible event, mutually exclusive events, independent event. Let us discuss about them. Simple event. It is a single outcome. Like while rolling a die we get 3, then it is a single outcome. Compound event. It is a combination of outcomes. Like while rolling a die getting 4, 6, 2, 1, 1, 3, etc. Certain event. Certain event will always occur and its probability is 1. Impossible event. It is an event which cannot occur or never occurs. Its probability is always 0. Mutually exclusive event. Mutually exclusive events are those events which cannot happen together. Independent events. One event does not affect the other is known as independent event. Let us discuss about axioms of probability. Statement 1. 0 less than equal to probability of E less than equal to 1. For each event, E is subset of S. Probability of sample space is equal to 1. This is also known as axiom of certainty. If A and B are mutually exclusive events, then we can give probability of A union B as probability of A plus probability of B. Here, probability of A intersection B is 0 because it's mutually exclusive. Classical definition of probability. So, the classical definition of probability can be given as probability of E is equals to favorable outcomes by total outcomes, if all outcomes in the sample space are equally likely. Like example, the probability of getting a die when the die is rolled is given as probability of A equals to 1 by 6. Let us discuss about conditional probability. Conditional probability. Probability of event A given that event B has occurred. That is, probability of A by B is equals to probability of A intersection B by probability of B, where probability of B is greater than 0. Or we can also give this as probability of B by A equals to probability of A intersection B by probability of A. Here probability of A is also greater than 0 because probability A and B are at the denominators. Independent events. Two events are said to be independent if they does not affect the other. Like probability of A intersection B is equals to probability of A into probability of B. If probability of both heads can be given as 1 by 2 into 1 by 2, that is 1 by 4. Now let us discuss about random variables. A random variable assigns numerical values to the outcome of a random experiment. So it is of two types, that is discrete random variable and continuous random variable. Discrete random variable gives finite countable outcomes. Continuous random variable gives infinite measurable range. Probability distribution. Probability distribution are three: probability mass function, probability density function, cumulative distribution function. Probability mass function contains discrete variables. Probability density function contains continuous variables. Cumulative distribution function contains probability up to a value. Expected value and variance. So these are two concepts in probability. Expected value is denoted by E of x. Average value of a random variable is known as expected variable. Variance. Variance is given as var of x. It is spread of random variable values. Like for example, if we take when die is rolled, its expected value, that is E of x, is 3.5. 3.5 is the average value of that experiment. Variance x is given as 35 by 12. Law of large numbers. So law of large numbers is observed when trial increases, the observed frequency approaches the theoretical probability. Like example, tossing a coin many times. Portion of head is 0.5. That is 1 by 2. Applications of probability. So these are the 5 applications of probability. They are risk analysis and decision making, weather forecasting, machine learning and AI, gambling and games, quality control in industries. Conclusion. Probability theory provides a mathematical foundation for analyzing uncertain events. Random experiment forms the basis of probability. Applications spans across science, technology, and daily life. So the main three concepts in probability is classical definition of probability. So it is very basic and it shows how it gives probability, like it is nothing but division of favorable outcomes by total outcomes. When we can also see when a coin is tossed, the probability of getting head is 1 because the other side is tail, and total outcomes are 2. So it is given as 1 by 2. Or when we take the probability of getting head, the probability of getting head is 1 because the other side is tail, and total outcomes are 2. So it is also 1 by 2. So in the case of dice, the same thing happened. Die have 6 sides. It contains 1, 2, 3, 4, 5, 6 numbers on it. So the probability of getting 4 out of 6 numbers is 1 and total outcomes are 6. So the probability of rolling a die is 1 by 6. So conditional probability is the main concept in probability. So it is only defined when event A is given and B has occurred. When A is given, then only B has occurred. Then conditional probability is verified. That is, probability of A by B is equals to probability of A intersection B by probability of B. So whenever any number in the denominator, it cannot be 0. So probability of B is greater than 0. Or we can also give for other case like probability of event B given that event A has occurred. Then the formula changes. It is given as probability of B by A is equals to probability of A intersection B by probability of A. So here also the same condition, probability of A is always greater than 0. It never be equals to 0 because denominator cannot be 0. Independent events. So what are independent events? Independent events are those events which does not depend on each other. So if the two events, when we consider two events A and B, the probability of them will not depend on other. Like probability of A intersection B is always probability of A into B. So if both heads means two dice are rolled, when two coins are rolled, then only we'll get the probability of both heads. So at one coin, probability of getting head is 1 by 2, and the other, for other coin, probability of getting head is 1 by 2. So 1 by 2 into 1 by 2 is equals to 1 by 4. So these are 3 important topics in probability. Thank you.